In this video, we're going to take a look at how to solve a system of equations, and we're going to focus on the comparison method this time. There'll be other videos out there for the other methods. So to solve a system of equations means we want to find the values of our variables, that's just our letters, usually that's x and y, that satisfy both equations. Another way of saying that is just what pairings of x and y will work in both equations. Again, it's important that we keep the same pairing of our variables. Now, if we're dealing with linear functions, so if both equations are linear, the system of equations has one of either three possibilities. And this basically happens if I have two straight lines. Either there's only one pairing of the variables that works with both equations. This is usually the case. That means I have two straight lines that are crossing only once. It's also possible that there's no pairings of the variables that satisfy both equations. And that just basically means that the lines are parallel and would never cross. And then it's also possible that all pairings of the variables satisfy both equations, so that we'd have an infinite number of solutions. And this could basically mean that the lines are actually the same line, just usually written in a different form, and something we call concurrent lines. We're going to focus only on this first possibility. It's the most popular one, and these two situations are kind of unique and really not that difficult to deal with. So let's take a look at an example. So here we've got two linear equations, both written in functional form, or y equals ax plus b. I'm actually going to call this one y1 and y2 so we can separate them. And we want to find out, well, what point do these two lines cross? Now, when they cross, we'll know that y1 equals y2. And I want to say, so well then, well, for what value of x does y1 equal y2? And to do that, I'm going to take my y1, I'm going to replace it with 2x minus 9. And since they're equal, I can do that. Over here, I'm going to do the same thing. I'm going to take y2, and I'm going to replace it with 3x plus 1. And what we've done now is we've created an equation, ties into this, but we only have one variable now. Up here, we couldn't solve anything. We didn't have any numbers, and y1 and y2 are a little bit different, so we can't just solve for y. But down here, we've got only one variable, x, and so you should be able to use algebra that you should already know in order to solve x. So basically all we have to do now is we'll bring all of our x's to one side, take all of our numbers to the other side, and then divide to find out x. So let's do that. I'm going to start by adding 3x to both sides. 2x plus 3x is 5x. So over here I've got 5x minus 9. Let me just tidy this up a little bit. So over here I've got 5x minus 9, and then negative 3x plus 3x, so that actually cancels out. So over here I'm left with just 1. Now we're going to add 9 to both sides, so we have all our numbers together. Of course, it cancels out over here, and I'm left with just 5x, and 1 plus 9 is 10, so 5x equals 10. And now I've got to get rid of the 5. Remember, this is 5 times x, so to get rid of it, I'm going to divide by 5, and whatever I do to one side, I have to do to the other side. 10 divided by 5 equals 2. So this means that if x is 2, y should be the same in both of these equations. Well, let's find out then what is y going to be in these equations. To do that, it should be pretty basic. I'm just going to take my x and I'm going to replace it with 2. Since x equals 2 at that point, I just want to know, well, what is my y coordinate going to be? And then, well, 2 times 2 is 4. 4 minus 9. So that means y1 equals negative 5. And if we've done this right, that means that these lines should cross at the point 2, negative 5. It also means if I were to take these values of 2 and negative 5 and put them into my second equation, that one should also balance or work. So we're going to check it. And to check it, we're going to do just that. We're going to use the second equation. Now, it's really important that you check your work in this case. Systems of equations, the check works really well. And if your check is valid, you'll know that you've done the entire thing correct. And when you get it right, that builds a lot of confidence. And if you made a mistake and your check doesn't work, that means you can go back, and if you've got all your work shown like I have here, you should be able to figure out where you made your mistake. And most of the time, it's just a small, careless mistake. Maybe you made a mistake adding or a little arithmetic error, or maybe you made a mistake with your signs, so on and so forth. So, like I said, when I'm checking, I need to use the other equation because I want to confirm that it works in there as well. And all I'm going to do is I'm going to take my value of y and place it in for y, and take my value of x and place it in for x. So if this all works out, negative 5 should equal negative 3 times 2 plus 1. And I'm going to put negative 6 plus 1. Negative 5 equals negative 5. And that's true. So our check works out. And that means that our answer is correct. And there you have it. Thanks for watching.